Good morning, everyone. I'm Sourabh Chouhan, roll number 0827CS221271, and I'll be presenting on vector similarity search and its evolution. In this presentation, we'll explore how search technology evolved from simple key-based system to modern vector-based AI search, which powers things like Google Search, ChatGPT, and recommendation systems such as Netflix and Spotify. Let's begin by understanding what vector similarity search actual actually means. What is vector similarity search? Vector similarity search is a method of finding similar items by representing data as numerical vectors in a high dimensional space. Instead of relying on exact keyword matches, it measures the mathematical distances between two vectors. For example, for example, using matrices like Gaussian similarity or Euclidean distance. The closer two vectors are, the more similar their meanings. This allows us to find semantically related content. For intensive searching for doctor might also show results related to hospital or medicine. It's a major shift from just matching word to understanding meaning. Traditional approaches to similar search. So before vector similarity search, we used traditional search method. The linear search method checked every item one by one, simple but extremely slow for large database. Then came inverted indexes, which power traditionally search engine. They mapped keyword to documents, making keyword based search faster. However, this system has limitations. They couldn't handle content, synonyms, or semantic meaning. For example, search for automobile wouldn't return result for car. This lack of semantic understanding led to the rise of vector-based approaches. Vector embeddings fundamentals, transforming data into high-dimensional mathematical representations. The real breakthrough come with vector embedding. So what is embedding? Embedding are numerical representations of data like text, image, or audio that capture semantic meaning. Words or items with similar meaning end up close together in vector space. For example, king and queen are near each other, while cat and kitten also share proximity. This concept enables computers to understand relationships and analogies between words or concepts, something traditional search could never do. Let's move to the next slide. Modern vector similarity algorithms. So there are some points. LHS, locality sensitive hashing, FAISS, ANNOY, ANN techniques. So LHS, locality sensitive hashing. Use hash function to group similar vector into buckets. So these points are high hash similar vector to same buckets, probabilistic approximate search, sublinear time complexity, trade-off between speed and accuracy. FAISS, developed by Facebook AI. provides GPU acceleration for extremely fast searches. So this is Facebook AI Similarity Search, GPU acceleration support, multiple indexing algorithms, billion scale vector search. So my so next point is Annoy by Spotify. Builds tree structures for quick vector lookups like approximate nearest neighbors, tree based indexing structure, memory map file, read only after building, and NN techniques. It is hierarchical, navigable small word, product quantization, PQ, inverted file index, IVF, graph based algorithm. Moving to the next slide. Vector databases and infrastructure. To support large scale vector operations, specialized databases were created. Example includes Pinecon, Viaviate, Milvus infrastructure. So Pinecon, a fully managed cloud based vector database service, Viaviate, which integrates vector search with knowledge graph. Milvus, an open source option that provides distributed scalability and also multiple index algorithm support. This platform managed indexing, querying, and updating high dimensional vector in real time. Something traditional database like MySQL and MongoDB were never designed for this. This infrastructure is the backbone of modern AI powered search and recommendation systems. Moving to the next slide. Real world applications. Vector similarity search has countless real world applications, recommendation systems, semantic search, image recognition, and AI application. Moving to the recommendation system. So Netflix or Spotify find movies or song you will be by comparing user preference vectors. Search engines. Google uses vector search to understand what you mean, not just what you type. Facial recognition identifies the same person when lighting and angle changes. AI chatbots like ChatGPT retrieve relevant knowledge by comparing semantic vector similarities. Essentially, any application that needs to understand content or user intent uses vector similarity under the hood. Moving to the next slide. Future trends and evolutions. Emerging technologies and the roadmap ahead of vector similarity search. Looking ahead, the evolution of vector similarity search is accelerating. Hardware acceleration with AI chips and GPU will make search even faster. Multimodal embedding will combine text, image, video, and audio into unified representations. Integration with large language model will allow system to reason and retrieve information more intelligently. So quantum computing integration has quantum algorithm for expansion speed up, hybrid quantum classic architectures, quantum approximate optimization, neuromorphic computing. It has pointer brain inspired processing architecture, ultra low power consume, real time adaptive learning. What about performance breakthrough? Their points are sub millisecond query response item, trillion scale vector indexing, 99.9% plus accuracy at scale, edge and distributed system has points, federated vector search networks, mobile optimized algorithms, cross platform interoperability. Moving to the conclusion, to conclude, vector similarity search has completely transformed how we relate information. We evolved from exact keyword matching to semantic understanding, enabling AI systems to deliver more accurate, meaningful, and human-like results. So, thank you for listening. I hope this presentation helped you understand the evolution and importance of vector similarity search.